Hi, kids. I'd like to take a few minutes to go over this diagram with you so that you can better understand it and be able to tackle some questions that I ask later. This diagram is from NASA, a reputable science institution. And this means that NASA is about developing theories to make sense of the natural world. NASA is also in the enterprise of establishing facts. That is to say, things that are not up for debate. I want to say that because oftentimes when we encounter topics like the carbon cycle, we are faced with controversy, speculation, and matters of opinion. Now, some of that interpretation is valid. There are some things that are debatable when it comes to the carbon cycle. But too often, we are presented with debate and opinions where they have no basis. There are things called facts, and facts are fundamental truths. When it comes to the carbon cycle, and anything else under the realm of science, we ought to leave it to the scientists to tell it like it is. Unfortunately, we often find that politicians, radio personalities, and pundits, who almost never possess degrees in science, are more than willing to sit in front of a camera and provide their points of view, which, by the way, are hardly ever supported by facts. That's where I come in. While I'm not a full-time career scientist, I do possess a science degree, and I consider it my job and obligation to ensure that you learn the facts. That's important, because if you're unaware of the facts, you can very easily be misled and literally lied to from people with self-serving interests. And oftentimes, such people take advantage not only of your lack of knowledge, but also of the fact that the carbon cycle is highly complex, and so they know that you'd be unlikely to fact check their claims. I'd like to help you to not become one of their puppets. Now, as with any diagram, it's important to analyze it carefully so that you understand the information. If we look here, we see that the numbers are in gigatons of carbon per year. Now, a gigaton is equal to 1 billion metric tons. That's not the same as a ton, as we use it here in the United States, which is 2,000 pounds. A metric ton is a bit more, 2,205 pounds. The bottom line, these numbers represent huge quantities of carbon. Now, it also says here that numbers in parentheses represent carbon that is in any one pool or area at any time. For example, if we look here in the upper left, we see that there are 800 gigatons of carbon in the Earth's atmosphere. That's such a large amount of carbon that I wanted to try to scale it down a bit for you. If my math is correct, you would need 123 billion male African elephants to equal the weight of all the carbon in the atmosphere. This doesn't really help. So let's try the typical Class C school bus. You'd need almost 71 billion of them to equal all of the atmospheric carbon. Still, not very useful. It's hard to imagine that many school buses. Okay, so let's go big, like the Empire State Building big. It turns out you'd need almost 2.5 million of them. I don't know about you, but I'm still scratching my head. So how about something much larger than a scrawny skyscraper? How about a mountain? And not just any old mountain. Let's go with the mother of all mountains. Yes, let's imagine Mount Everest. Guess what? You need almost 5 of them. That's right. It would take almost 5 Mount Everests. That's a lot of rock to equal all of the weight of the carbon above your head right now. Of course, most of you still have yet to see Mount Everest in all of its glory. So we're still at a bit of a loss here. Oh well, I tried. Let's get back to the graphic. It says here that numbers in red are the result of human emissions. And if we look here, we see that humans are adding 9 additional gigatons of carbon to the atmosphere each year. Now, you'll see elsewhere on this diagram that our planet is doing what it can to remove some of the additional carbon from the air. But if you analyze this closely, you'll see that some still remains. Well, that's it for now. I'd like you to do the rest on your own. And when you get to a question that is difficult for you, remember this. Education is supposed to be challenging. If it were easy, you wouldn't get any more intelligent, would you?